And welcome back, and I thought we'd do something slightly different today, similar to one we've done with the normal GCSE, but I thought we'd actually look at a Further Maths AQA Level 2 certificate paper. Now, this is a bit different to the GCSE. So the GCSE syllabus is pretty similar across all boards. So AQA is pretty similar to EdXL, which is pretty similar to OCR. There may be a slightly different format to questions and a slightly different layout, but it involves exactly the same syllabus. With the Further Maths, the EdXL one is quite different to the AQA one, which again is quite different to the other ones, such as say AdMaths. However, this is the one that most schools tend to take. And that's because the overlap with the normal GCSE is pretty high. And as you'll see, if you haven't seen one of these papers before, you can probably do most of it with normal, albeit very good GCSE knowledge. It just involves a lot of algebra and a lot of index rules and similar, just without a lot of the drawing or the cumulative frequency or whatever it may be. Now, I have not looked at this paper, although in fairness, I must point out, I taught Further Maths GCSE probably now 3-4 years ago. And this is a new paper, so this is the 8365 paper, which came out, well, it says 2020 here, but I think it came out about 3 or 4 years ago, and my group were one of the first years to take it. In that sense, I've largely forgotten what's going to appear on here. Obviously, some of the questions might ring a bit of a bell, but I think it's always interesting to watch somebody go through a paper, see how they encounter different questions and see what they do. I think that's a bit more instructive than just watching someone do it perfectly. So anyway, let's see how we go. I've got an hour and 45. I strongly doubt it's going to take me that long, only because I know what to do on each question. And again, this is the AQA specimen paper. So it's a good idea of how the current exams look, but exams do, let's say, mature over time. They do change a little bit, but it should be a good representation of what you're going to get. Final thing to note, this is the non-calculator paper, which means I should just be able to do it without touching a calculator, and actually intentionally the questions are designed to check your understanding of various maths techniques. So anyway, where are we? Let's go. I am going to mark this tomorrow. I'm going to mark it fairly and accurately, or as fairly as accurate as I can, and let me know how you think I've done in the comments below. Enough talking, let's get started. Right, first question. Now, I'm going to try and keep the working near the question, so I won't always use a space provided, if only so you can continue to see the question. But in these first few questions, it's not too bad, is it? I've got a load of space, and so therefore I should be able to fit it in. So this is an index rules question, and I'm going to do a lot of these questions almost straight off. I'm going to talk through them, but kind of do them in one go where I can. So for example, this is index rule, so it's y to the 6 times y to the 1 means add 1, divide by y to the m means take away m, and that all is equal to y to the 4, which means 6 plus 1, which is 7, minus m is equal to 4, so m must be equal to 3. And that is the first question done. Next question, oh actually it's a continuation of the question, isn't it? I've got another one below, so 3 index rule questions, or maybe more below. Right, so what do we have here? Another index rule question. Okay, clever question. I need this to be 1 because 1 times something is itself. Anything to the power of 0 is always 1, so therefore it must be the case that n is equal to 0. That's not terrible. Next question. In another index rule question, I don't know if it's the last one, there might be one on the next page, but it's probably the last one of this section. It's already in base C, so I'm going to skip writing out the index numbers and just write down that 5p must be equal to 2 times 6, which is 12, which means that p must be equal to 12 over 5. So far, these aren't too bad, are they? Next question. On that one, any equivalent to 12 over 5 is fine. Right, solve. That is a D. Let me just zoom in. That's definitely a cubed. So I'm just going to unwind this. So cube both sides gives me 8. So I get 7x minus 13 is equal to 8. Add 13 to both sides means 7x is equal to 21. Divide by 7, which means x is equal to 3. So far, these are not too bad, are they? Next question. Question 3, 4 marks. Okay, so this is an identity question, and here I can see that that's an identity, which means for all values of x, the thing on the left is equal to the thing on the right. So I'm going to do this by just expanding. So if I expand this, I've got 6ax minus 3a plus 4ax plus 20 is equivalent to, not equal to, 60x plus b. Now if I compare the coefficients of the x, I've got 6ax plus 4ax, which is 10ax, and that is equal to 60x, which means it must be the case that a is equal to 6. If I compare the coefficients of the constants, in other words, the constants, well, minus 3a plus 20 is equal to b, so minus 3a plus 20 is equal to b. A is equal to 6, so minus 18 plus 20, which means that b is equal to 2. And let's just write these answers down here. So I've got a is equal to 6 and b is equal to 2. Final answer, happy with that one there. Next question. Right, what do I have now? ABC is a straight line. So it's one of these ratio lines questions, and it tells me that A to B and B to C is 5 parts, 2 parts, which means there's 7 parts overall. So I'm going to write that down here just in case I need it. Then I'm going to work out the coordinates of C by doing... okay, so I'm going to start with AB. So AB is a vector, goes across, well, 3 to 5 is across 2, and 7 to 5.5 is minus 3 over 2, or minus 1.5. Now, A to B is 5 parts, A to C is 7 parts, so I'm going to say that A to C is A to B times 7 over 5. In other words, I'm scaling it up. So that's times 2 and minus 3 over 2. Now, non-calculator paper, so there's no getting my calculator out, so I'm just going to work this out. So 7 over 5 times 2 is 14 over 5. And 7 over 5 times minus 3 over 2 is minus 21 over 10. Okay, that is the vector to get from A to C. That is not where C is. So C as a coordinate, well, I'm going to start from A, which is 3, 7. So it's 3 plus 14 over 5 and 7 minus 21 over 10. In other words, I'm applying the vector to the point A. A is actually a position vector, is really what I'm doing, but don't worry about that. Right, 3 plus 14 over 5. Well, 3 is the same as 15 over 5. So 15 plus 14 is 29 over 5, and 7 over 10 is 70 over, or I should say 7 is 70 over 10. 70 minus 21 is 50, 49 over 10. And I think that's perfectly acceptable. I could write as a decimal, so 29 is 5.5 and 4/5, 5.8, and 49 is 4.9. Either of those two answers I think are fine. Question done. Yeah, I'm happy with that one. Next one. Okay, so the differentiation question. What makes this slightly tricky is you don't know yet how to cope with the 1 over. So you're expected to write this as 3x to the minus 2. So when you differentiate, you get 20x to the 9, bring down the power, take away 1 from the power, and minus 6x to the minus 3. And there's nothing else to do there, is there? Next question. Okay, I'm going to zoom in a bit just to make sure I can see the index powers correctly. Simplify fully. Now the word fully and simplify suggests at least a couple of steps are going on here. So, well, let's just simplify and see what happens. I'm going to factorize the top. So I'm going to take out a 5xy, and that's going to leave behind a 3x minus 5xy. I'm going to factorize the bottom by taking out 4, okay, and it's a 3x minus y. I can cancel the factors top and bottom, and that's just going to leave me with 5xy over 4. I'm pausing because there's only really one step there. Normally there's a bit more to do. But anyway, happy with that, 5xy over 4. Or 5/4 xy, I think will be fine as well. Next question. Oh God, what do we have here? A, B, C, D is a rhombus, right? Rhombus means all the sides are the same. So these are all the same length, which means they're all 8. ABC 60, which means because it's a rhombus, that's 120, and the opposite angles are the same, so that's 60 and 120. What am I doing? I'm working out the area. So actually, I don't need any of this, do I? I'm just going to say this is 2 triangles. So it's going to be the area of 2 triangles. That's going to be 2 times a half AB sine C, which is going to be a half times 8 times 8 times sine of 60, which this is an exam, so I'm just going to go straight to root 3 over 2. And that's going to give me, well, 2 times a half goes away. 8 times 8 is 64. 64 divided by 2 is 32. So that's going to give me 32 root 3. What have I done? Give your answer in the form. Right, I've done that. All right, happy with that. Next question. The curve gives me a curve, maximum, minimum. Oh God, what's it going to make me do here? Intersects the y-axis at n. Curve crosses the x-axis at 3 distinct points on the axis below. Okay, it's just a sketching question. I thought it was going to be much more difficult. Oh, it's only 3 marks as well. Maybe that should have been a key. Right, it's a x cubed, which is positive, so it does that. My maximum is here, or it's actually a local maximum. My local minimum is here. So I'm then going to sketch the graph. 0 lies in between these 2 points. So in other words, I'm just going to get a graph that comes up, crosses here, then comes down and goes up again. That, and that are the points that I need. So what are they? So L is minus 113. I'm just going to write that L is minus 113. I can't remember them. M is 2 minus 14. So M is 2 minus 14. I have to say, my scale looks broadly okay. Don't worry too much about it if it's not. Don't spend ages mapping out a scale. Doesn't matter. It's just about you sketching and labeling the points. Intersects the y-axis at n, and n is x equals 0, which means that y equals 6. So n is the point 0, 6. Right, the curve crosses the x-axis, done that. On the axis, sketch the curve, done that. Label the points n, m, n, I've done that. I think that's it, isn't it? Yeah, happy with that. Next question. A, B, C, and D are points on a circle. B, C, okay, so it's label all the points. Oh, okay. Prove that AC is a diameter. Now, it's a circle theorems question. It's based on the idea if that is 90 degrees, it means AC must be a diameter. And if AC is a diameter, it means that must be 90 degrees. It's what's called an if and only if relationship. How are we going to do this? Okay, I'm going to start by saying that A, B, C, D is a cyclic quadrilateral. And because these are points in the exam, I'm going to write all this down. I don't normally write these down on my daily sheets. Cyclic quadrilateral, therefore, what can I say? Angle C plus angle A equals 180 degrees. In other words, opposite angles are equal. Therefore, it must be the case that x plus 2x plus 4x plus 3x, so in other words, x plus 2x plus 3x plus 4x is equal to 180. X, 2x, yeah, I got that right. 1, 3, 6, 10, so 10x is equal to 180, which means that x is equal to 18. Right, now consider one of the triangles. Let's consider triangle ACD. So consider ACD. So I'm going to roughly sketch it. It doesn't really matter if I'm accurate. So consider ACD. So A, what's my order? I know it's the other way around. ACD. And this we now know because 2x is 36 and 3x is 3 times 18 is 54. Now, I just need to make a statement as to why angle D is 90 degrees and then explain what that means. So angle D, so D equals 180 minus 36 minus 54, which equals 90 degrees, yes it does. I'm going to write angles in a triangle, total 180. Don't write in this box here like I'm doing, but I'm on an iPad, so it's fine. And then therefore, as D is 90 degrees and a triangle in a semicircle is right angled, I have to write it down here. Have I got any space down here? No. Is right angled. Then AC equals, well, what am I showing? So I'm showing that AC is a diameter, so AC is a diameter. Now, we'll do the marking tomorrow, but you can see what I've tried to do is try to explain why this must be 90 degrees, and therefore I try to explain this circle theorem rule about angles in a triangle in a semicircle make a right angle triangle. I think I've ticked all the boxes. As you'll see tomorrow, when you mark this, you're just looking for various trigger words. I think I've got them all. We'll find out tomorrow. Right, next question. Question 10. I don't know how many questions there are, but let's see how we go. Must be at least halfway. F of x equals 9x to the power of 1. G of x equals this. Give Okay, I'm just going to put the number straight in. So therefore 9 times a third over 2 to the minus 1 is equal to 1 minus p times a third cubed, which is obviously 1 over 27, but let's do it step by step. Now 9 times a third is 3, 3 over 2 to the minus 1 reciprocal is 2/3, so 2/3 equals the square root of 1 minus p over 27. I'm hoping this is going to work out to be a nice number, but let's carry on. Then I can square both sides, so 4 over 9 equals 1 minus p over 27. Okay, the 9s are going to cancel a bit here, aren't they? 1 minus both sides, therefore 5/9 equals p over 27, which means that p equals 27 over 9, which is 3. 3 times 5 is 15, which means that p is equal to 15. Yeah, happy with that. Next question. Here we go. There's always going to be a circle theorem question. A circle centre C touches the y-axis at the point 0, 2. Okay. The line y equals k intersects the circle at the points 1k. So here's my y equals k here. Then what am I doing? Oh, that's down here. Work out the equation of the circle. Okay, so the equation of circle means I need the coordinates of C and I need a radius. So what do I know? Well, I'm going to start by just drawing something because I don't really know what to do here. So I'm going to join these up. Okay, hasn't helped. And then, okay, right. So I've noticed the difference between here and here is 4, which means that must be 2 and that must be 2. Okay, I'm not sure I've worked this out. Okay, spotted it. This is 1 because it's 1 across, and this is 2, which means my C is 3, and actually already tells me the height, doesn't it? So it's 3, 2. So I've got my centre. What I need now is my radius, which I've just done because that's from here to here. So my radius is 3. Oh, this is actually not as bad as it looks. So it's only 3 marks. So it's going to be x minus 3 squared plus y minus 2 squared is equal to 3 squared, which is the radius, which is equals 9. And that's right. Yeah, I'm happy with that. That's fine. Next question. Right, so what do we have here? Got a triangle, gives me some lengths. Okay, this is going to be a cosine rule question. So B, I'm just going to write this out because again, it's a non-calculated paper. I'm expecting a lot of this to cancel. So BC equals B squared plus C squared. So it's going to be 16 plus 49 minus 2 times B, which is 4, times C, which is 7, times cos X, which is given me up here, is minus 2 over 7. And that cancels one of my 7s, I can see that already, and I changed my minus to a plus. Right, let's try and not mess this up. So 16 and 49, well 50 and 16 is 66, that's going to be 65. Sorry, a bit messy. 2 times 4 is 8, the 7's cancel, times 2 is 16. I'm hoping this can be a nice number. 65 plus 10 is 75, plus 6 is 81, yes it is. 81, square root of 81 is 9, BC is 9. Excellent. Nice question. Right, next one. Got rearranging. Now, as you've seen any of my daily videos, there's definitely a bit of a technique that happens here, isn't there? So I'm just going to do it straight off. So multiply by the denominator, which is going to give me tw squared minus 2 is equal to 3w cubed plus a. And I said squared, but I did mean cubed. Then I'm going to collect my cubes. So that's going to give me w cubed t from this one on the left minus 3 from the one on the right is equal to a plus 2t. Always a bit risky doing too much in one go, but it's an exam, so I'm doing it for speed. So w equals a cube root of a plus 2t over t minus 3. I think that's my answer. I'm happy with that one. Yeah, let's go with that. Good. Got my cube root in. I think, yep, good. Happy. Next question. Okay, a bit of surds here. It tells me how to leave my answer. I think I'm just going to go for it. So root 3 minus 7 over root 3 plus 1. Now multiply top and bottom by the denominator with the sign changed. So root 3 minus 1. And that's going to give me, right, let's do this carefully. So root 3 times root 3 is 3. Root 3 times minus 1 is minus root 3. 7 root 3 is minus 7 root 3, and 7 times 1 is 7. And on the bottom, square the first one, which is 3, square the second one, which is minus 1, because there's a minus. Gives me 2. Is that going to cancel down? Yes, it is. 3 plus 7 is 10, and minus root 3 minus 7 root 3 is minus 8 root 3. Divide all that by 2. I've got it in the right format, thank God for that, which is going to give me 5 minus 4 root 3, and that is my final answer. I'm happy with that one. Next question. Right, point A lies on the curve y equals this. The x-coordinate of A is minus 4. Okay. As soon as I see the word normal, I'm thinking tangents, and I'm thinking differentiation, and I'm thinking make sure I get my tangent and normal gradient correct. So let's do this carefully. So dy dx is equal to 2x plus 5. What am I doing? The x-coordinate of A is minus 4. Okay, right. So I need to work out the tangent gradient. So at x equals minus 4, dy dx equals, well, 2 times minus 4 is minus 8. Minus 8 plus 5 is minus 3, which means the normal gradient is equal to a third. I need the y value, don't I? Yes, okay. So at x equals minus 4, y equals minus 4 squared, which is 16. Minus 4 times 5 is minus 20, plus 8. 16 plus 8 is 24, minus 20 is 4, which means my A is minus 4, what did I just work out? Minus 4, 4. Good, okay. Then I need to put all that in to show the equation the normal. So the equation of my normal is going to be y minus y1, which is y minus 4, equals a third normal gradient, times x minus minus, which is plus 4. Let's then expand this. I've got 3y. Now I'm showing, so I don't just do it in one go. So 3y minus 12 is equal to x plus 4, which means that 3y, what does it want? 3y equals x plus, yeah, okay, good. So 3y equals x, 4 plus 12 is 16, and QED, I have done that question. Great. Next question. Oh, no, we continue. Right, so what do we have? Right, okay. The normal at A also intersects the curve at B. Work out the coordinates B. Oh, so I need to work out where they meet each other, don't they? So it's going to be 3y equals x plus 16. I think that was it, wasn't it? 3y equals x, yes. And then the original equation was x squared plus 5x plus 8. So let's write that down. So y equals x squared plus 5x plus 8. Now, difficult way is I divide everything by 3 and put it into the right equation. Easier way is I'm going to multiply the equation on the right by 3. So 3y equals 3x squared plus 15x plus 24. Then this is equal to this, which means that, now, yeah, let's do it in one go. So 0 equals 3x squared minus x from both sides is 14x. Minus 16 from both sides is 8, and I need to factorize this. No, I don't think I can factorize this, can I? No, I'm just going to go for it in one go. Let's do the quadratic formula, it's safer. So therefore x equals minus 14 plus minus the square root of 14 squared, 196, minus 4, let's do it over here, 4 times 3 is 12 times 8, 96 isn't it? Oh yeah, it's a 96, which is 96, that's nice, works out to be 100, divided by 6, which is minus 14 plus 196 minus 96 is 100, divided by square rooted is 10, so minus 14 plus 10 over 6, or minus 14 minus 10 over 6, which equals, well, minus 14 plus 10 is, of course, minus 4 divided by 6 is minus 2/3, is that right? Yeah. And minus 14 minus 10 is minus 24 divided by 6 is minus 4. We already have that one, so my answer is going to be x equals minus 2/3. Wow, what a good question. Next question. God, we've got to be close. Well, how many questions are there? 16, 17. Sorry, I know you're watching a screen flash by. Oh, that's it, 20. Right, and what question were we on? We're on question 16. Okay, 5 more questions. The coefficient of x4 in the expansion of this to the power of 6, so I've got a 6 up here, is 60. Right, okay. Pascal's triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. Now, actually, I know all those. I don't know my 6th one. So 1, 6, 15, 20, 15, 6, 1. What do I want? I want the coefficient of x to the power 4. Well, this is x6, this is x5, so this is x4. So this is the one I want. So that means that 15, which is my sort of like combination coefficient, times 2x to the power of 4, is that right? Yes, it is. Times a to the power of 6 minus 4, which is 2, is equal to 60. Now, hold on, work out the possible values. Okay, possible values means it's going to be a square root. 15 times 2 to the power 4 is 15 times 16. So 15 times 16 times a squared equals 60. Don't know why I've written 160, but 60. Divide by 15, which means it's 16a squared equals 4, which means that a equals plus minus a square root of 1 over 4, which is plus minus a half. Yeah, so it's a is a half or minus a half. Is that it? Work out the possible values. Done that? Yep, question done. Next question. Here we go. All right, if you watch my daily videos, you know I'm not a big fan of these, but let's just go for this anyway. Okay, so let's do 2 times 1. And then we're going to take away number 2 underneath. So 2 times 1 is 4a plus 2b minus 2c is equal to 16. And then just write down number 2 underneath. So 4a minus 3b minus 2c. Oh, good. I just noticed 2 things cancel. This is going to be much easier than I thought it might be. So 4a minus 4a goes away. 2 minus minus 3 gives me 5b. Is equal to, or minus 2 minus minus 2 goes away as well. So 5b is equal to 25, which means that b is equal to 5. Okay, good. I will say they don't have to be integers, but the fact that is an integer just makes me feel a little bit better about where this might be going. Next one, I've done 1, so let's do, up and down. 3 times 1 against 3. So 3 times 1 and 3. Let's pull this down, I can see it all in one go. So 3 times 1 is 6a plus 3b minus 3c equals 24. And then just write down the third one, so 6a, can't do when it's this far down on the iPad, plus 3b plus, that's right, 6a plus 3b plus c equals 0. So I was about to multiply them all by 3. Oh wow, actually this one's going to work as well, isn't it? So take this away, so 6a minus 6a goes away, 3b minus 3b goes away, and minus 3c minus c is minus 4c is equal to 24, which means that c is equal to minus 6. Great. Now let's write down number 1 without multiplying it by anything. So that is 2a plus b minus c equals 8. So 2a plus b minus c is equal to 8. I know that b is 5, so 2a plus 5. C is minus 6, so minus minus 6 is plus 6 equals 8, which means that 2a equals 8 minus 11, which is minus 3, which means that a equals minus 3 over 2. Wow, except for the last one, those numbers are quite good, weren't they? So a equals minus 3 over 2, b is equal to 5, and c is equal to minus 6. Okay, quick breath before doing the next one because we've flown through these. I've got a feeling a very hard one is coming up. Okay, question 18. Now, yes, I'm going to use the inverse approach. So what do I do to minus 2/3? What do I multiply by to make it 1? I multiply by minus 3 over 2. So therefore, I'm going to take this. Well, 12 times 4 is 48 plus 1 is 49 over 4. Minus 2/3, the opposite of that is minus 3 over 2, is what I'm trying to say. So minus 3 over 2, so that's the same as 4 over 49 to the power of 3 over 2, which is the same as 2 over 7 to the power of 3, which is the same as 8 over 343, and that is my final answer. Now, at some stage here, because I'm doing a square root, or could it be both answers? Could it be the negative answer as well? Because I did do a square root here. So I've got a negative number, and I'm squaring it. That will work, won't it? So is it plus minus 8 plus root 3? It's not clear. I think it's probably plus minus, but I'm going to leave it as a plus, although I'm not very comfortable about that. Right, this is where I'm going to drop the mark if I drop a mark so far. Let's come back to that. Right, next question. Use differentiation to show that f of x is an increasing function for all values of x. Right, okay. So increasing function is where the first derivative is greater than 0. So I'm going to first of all differentiate, because that's going to be a couple of marks even if I can't do the rest. So that's 6x squared minus 24x plus 25. Is that right? 6x squared minus, yeah. Then I'm going to need to show that this is greater than 0. So the technique I'm going to use is I'm going to complete the square, which shows that all values are above 0. So if I complete the square, that gives me 6x squared minus 4x plus 25, which is the same as 6x minus 2 squared minus 4 plus 25, which is 6x minus 2 squared. 6 times minus 4 is minus 24, plus 25 is 1. And now I just need to say a convincing argument. This is greater than 0 for all x as it's something squared. I don't need to explain that at length. This is obviously greater than 0. So therefore, f of x is greater than 0 for all x, which implies increasing for all x. Is that it? Use differentiation to show that f of x is increasing for all values of x. Yeah, I've done that. Good. Next question, and final question. Excellent. Right, show that. Now this is interesting because nothing says I have to go from left to right. So I'm going to start with the right, which is 2 minus 2 sine squared theta. I'm going to write down what I'm doing. So sine squared theta plus cos squared theta is equivalent to 1, which means that this is equal to 2 minus 2, 1 minus cos squared theta, which is equal to 2 minus 2 plus 2 cos squared theta, which is equal to cos squared theta, which equals to the left-hand side. So therefore I've proven it. I mean, that was all 1 mark. So I'm quite sure I didn't need to do that many steps, but done anyway. Next question. Hence. Right, so I must use the previous result. So hence solve. Okay, so what was the previous result again? So right-hand side equals... okay, right, so I'm changing the 2 cos squared theta for 2 minus 2 sine squared theta. So from A, this is equal to 2 minus 2 sine squared theta plus 3 sine theta is equal to 3, which I'm going to rearrange. So I'm going to rearrange it and multiply by minus 1 at the same time. So that means 2 sine squared theta minus 3 sine theta. 2 minus 3 is minus 1, but I'm changing the sign, so it's plus 1. Can I factorise this? I believe I can. It's 2 sine theta minus 1, because minus and minus make it plus. And then sine theta minus 1 is equal to 0, which means that sine theta equals a half, or sine theta equals 1. Now, what's the range? I'm doing it between 0 and 180. But not including. That's interesting. Okay, so sine theta equals a half implies that theta equals 30 or 150. Again, that's just me knowing my sine curves. And then theta equals 1 is when theta equals 90. So the answers to my question are going to be 30, 90, 150. Answer the question. Any more left? I am done. Let's end the video there. Now, do come back tomorrow. I'm going to mark my work. I'm going to mark it super fairly. I'm going to be super accurate. And actually, I'm going to be quite mean with myself because these are, it doesn't matter if I lose a mark. It's slightly embarrassing, but it's fine. It matters if you do. So come back tomorrow, watch me mark this, and, well, usual thing, please do like and subscribe. There'll be more of this coming to the channel. I will do probably one of the ad maths as well, some stage, maybe one of the Excel Further Maths. But either way, let me know. Also, let me know in the comments how you think I've done. What do you think I've got out of, what's the score? I don't even know what the score is out of. Out of 80. What do you think I've got out of 80? Let's see. Thanks all. See you for the next one.